Bhagya Harshit, you joined through two logins? Okay, okay. Yeah, yeah, okay, okay. Okay, thank you, Bhagya Harshit. So, I don't know why this is happening here. So take three columns and we are going to discuss how the each particle will behave in this case. So the first case, if I take the particle, negative particles, so if they take the negative particle and the magnetic field direction is outward, okay. So this is my field directions, outward, sorry, so outward. So then, so my charge is coming this like this. My negative charge here I have taken negative charge, it is moving in this direction. So obviously we know, so this charge are uniformly magnetic fields as we discussed in the earlier, and which is out of the system, out of the world. So definitely we know this is going to be circular motion like this, but this circular motion is anti-clockwise direction. Okay na? This is important, anti-clockwise direction. So the second case, I am taking that the charge is the negative only, and but the magnetic field is inward. So this is come by left hand Fleming rule. So tomorrow morning class we have to discuss that. What is the left hand Fleming rule? So this is the inward, and now take the negative charge, and it is moving in this. Definitely, to have take that circular motion as we discussed in the last class, but it should be clockwise direction. This is the clockwise direction. So the third case, it's opposite, and the third case we are discussing positive charge, and the same magnetic field is inward here. You already know what is this inward magnetic fields. This is the inward magnetic field. So the charge is moving, the positive charge is moving like this. Of course, it will make the direction, but the direction will be anti-clockwise. Anti-clockwise direction. Okay, chance. Okay, I'm writing in the next page. So now take that, the fourth one. Again the positive charge, and now the magnetic field be outward direction. So magnetic field is outward. Now we lost this, the control option. So let's take that the direction is outward. So that's why it's a dots only. and charge is this side, and we know it will make a circular path, and this is going to be anti-clockwise direction. Anti-clockwise direction. This is a very important. And generally in the question they will ask, so they will give you that one particle is moving, the particle is either positive or negative, which is moving perpendicular to the directions of the magnetic field. So is the directions of the magnetic field either outward and inward, they will ask you that what is the path, direction of the path.
Clockwise, sir.
Yes,
Clockwise, sir.
in this case anti-clockwise. Oh, sorry, clockwise. It is clockwise direction kada. Yes, this is the clockwise direction. Previous class is the anti-clockwise. Now we'll move to that another concept is motion of the charged particle on helical path. See, so what is the charged particle and a helical path? So ippadaka what we discussed? We discussed that the charge is perpendicular to the magnetic field. Okay. So when the charge we are entering inside, okay, so we are giving the charge in the 90 degrees. So that's why we can see that the 90 degrees, it has some angle. So let's take that example. In this case, so I am taking the coordinate axis like this, and each this is x, y, and z. And we know if the magnetic field is moving like this, magnetic field direction is this side. This is the magnetic field direction. So now I am giving the charge so towards the magnetic field, not exactly, not like this. I'm not giving the velocity like this. I'm giving with a certain angle with the theta, right? Like this I'm giving. So మనం last work ఏం discuss చేసాం, magnetic fields are like this, okay, and if I give that my any particle velocity like this, what is going to be, this is going to be circulate like this. But in this case I'm giving this with some certain angle. It's not exactly to the, this is the 90 degrees, I'm not giving the 90 degrees, I'm giving a certain theta. In this case how that particle is going to be behave. So generally this case the particle is going to be behave like this.
Magnetic field into or onto, sir?
ఇంటూ అంటూ కాదండి, ఇట్స్ ఎ ప్యారలల్ అండి, ఇట్స్ ఎ ప్యారలల్ టు ఎక్స్ యాక్సిస్. ఇంటూ అంటూ అనేది మనకి బోర్డు మీద ఉన్నప్పుడు చెప్తాం. సో దిస్ ఈస్ నాట్ ఏ ఇంటూ అంటూ, ఇట్స్ ఎ ప్యారలల్ టు ఎక్స్ యాక్సిస్. Technology, what happened? Hi Kushi, is this you only right?
Yes, sir.
Oh, very good. Yes, sir. Okay. So now let's take what is the magnetic force. We know, so QVB sine theta. So manaki in the last classes we have taken theta is the 90 degrees because now the charge is having the perpendicular to the magnetic field. That's why the theta is going to be 90 degrees. Is this okay? Everyone? Okay. Now, yes, Gandhi, you have doubt? Okay, Gandhi. So now, see, so this is the vector components. This is going to be v cos theta, and this is going to be v sin theta. This is going to be v cos theta. So now see, uh, in the previous class, so we have to we find that q v r is equals to mv generally. Okay, so but here the v is here we have taken the horizontal direction. That's why instead of v I am taking that v cos theta. So from this I can find that r is equals to mv cos theta by qbr. సార్ ఇది ఎట్లా వచ్చింది సార్ అంటే మనం జనరల్గా సో లాస్ట్ క్లాస్ వీ హ్యావ్ టు సబ్స్టిట్యూట్ ఈజ్ ఈక్వల్స్ టు హాఫ్. Here we have to substitute it mv square by r. We balance the equation, right? So there we find that so r is equals to mv by qb. So there here velocity, I am taking this my velocity of the particle is moving in the horizontal direction in a helical path. That's why I taken that this is the horizontal component. So here instead of the v, I have taken v cos theta. Is this understand why this formula is came?
కింద QBR అని ఉంది సార్.
Yes, it's QBR only. Sorry. QBK. Yes, it's Q. ఇక్కడ R తీసుకున్నాం కదా అందుకని Q. Now we have to find the time period. This is the important and helical path lo time period and frequency do not depend on C. So t is equals to t by m by qb. The same time period. So last class I mean ఇది ఇక్కడ డిరైవ్ చేశాను రఫ్ చేశాను. మన లాస్ట్ క్లాస్లో మనకి టైం పీరియడ్ అయితే ఏమైతే వస్తుందో ద సేమ్ టైం పీరియడ్ వీఆర్ గోయింగ్ టు గెట్ హియర్ బికాస్ the time period is not depend on the frequency. Time period and frequency is not depend on the velocity of the particle. So that's why the same thing it will come. So from this we know the frequency is equals to 1 by t. So kabatti it's going to be qp by 2 by n. సో మనం ఇంకొకటి కనుక్కోవాలి బికాజ్ ఇట్స్ ఎ హెలికల్ పాత్. సో హెలికల్ పాత్ అన్నప్పుడు ఖచ్చితంగా సో దేర్ విల్ బి ఎ డిస్టెన్స్ బిట్వీన్ టూ హెలిక్స్ దట్ ఈస్ కాల్డ్ పిచ్. దిస్ పిచ్ వీ హ్యావ్ టు ఫైండ్. The pitch of the helix is given by. Sir, what is the pitch, sir? See, take the definition of the pitch. Pitch is the linear distance. Online lo mana problem solve cheyalli ఎక్కువగా. The linear distance traveled in one rotation. Okay, so see, if it is traveled from like this, started from here and it came here and it will came here like this. If you do like this is called a pitch. So general ga if you do in the circular motion, you can call it as a ఎక్కడ రాసింది? Yes. See, if the circular motion, if it is do like this is called one revolution, right? Ade, it's moving forward. So my particle is moving forward. That's why it is started here and it started here. It will end here. So from this point to this point, I can call it is as a pitch. Okay. ఈ కాన్సెప్ట్ పక్కన పెట్టండి. This concept we will discuss this concept later. So what is the formula of the pitch? The pitch is equals to P is equals to T times of the V cos theta. ఏం లేదు, వెలాసిటీ ఈజ్ ఈక్వల్స్ టు డిస్టెన్స్ బై టైం. డిస్టెన్స్ అంటే ఏంది? వెలాసిటీ ఇంటూ టైము. వేర్ టీ ఈజ్ ఈక్వల్స్ టు టైం పీరియడ్. వెలాసిటీ అంటే మనకి ఎక్స్ యాక్సిస్ వెళ్తుంది కాబట్టి వి కాస్ థీటా తీసుకున్నాం. ఓకేనా? దట్స్ వై హియర్ వీ హ్యావ్ టేకెన్ దట్ వి కాస్ థీటా. సో వాట్ ఈస్ ద టైం పీరియడ్? Time period is 2 pi m by qb. And v cos theta. This is the pitch of the particle. Okay. So there are few things are there. Note points. So these points are very important. Please remember. Nenu already cheppanu. This is the one revolution or one rotation. So one rotation in circular motion, which is equals to one pitch in helical rotation. Okay, helical rotation or helical path or helical motion. This you have to be remember. So kabatti, what is the one rotation? One rotation is nothing but 2 pi. And what is the one pitch? One pitch is equals to, sorry, one pitch is equals to 1a. So pitch is nothing but it's going to be pi also. So 2 pi ni usually we will call it as a time period. So kabatti we are going to 2 pi as the t. Okay, so this you need to remember. General వాళ్ళు ఏం అడుగుతారంటే one rotation equals to one pitch. They will ask in the question that they are giving that number of the pitches. They have to convert it into the rotations. So kabatti this is important. And the second point, so number of pitches equals to number of rotations. ఇప్పుడు నేను అదే చెప్పాను. So they will give the number of pitches, we have to convert it to the number of rotations. So what is the number of rotations ante enti? Number of rotations is nothing but number of repetitions. అలాగే అనొచ్చు, లేకపోతే మనకి నెంబర్ ఆఫ్ హెలికల్ టర్న్స్ అని కూడా అనొచ్చు. సో దిస్ ఈజ్ ఇంపార్టెంట్. నెక్స్ట్ పాయింట్ నెంబర్, if pitch value is p, then number of pitches obtained in length L given as. So number of pitches is 1 by p, and the time required is equals to t is equals to 1 by v cos theta. So it's a simple problem only. So these 2 points are there. So next concept, there is a Lorentz force. No, I will not discuss the Lorentz force in the online, and I will discuss the Lorentz force in offline only. Now I will take you the few questions based on these problems. We will discuss. So సో ఈ హెలికల్ పాత్ కన్నా ఆ సర్క్యులర్ పాత్ ఈజ్ వెరీ ఇంపార్టెంట్ అండి. Definitely they will ask a few questions from the circular path. Let me take your questions. There is a low in the force is there. Low in the force is also. Yes, it's a very beautiful problem. So let's come to that. The questions only. So we'll talk the questions only in the online classes. More number of questions. So electrons move at right angles to a magnetic field. And the magnetic field 1.5 into 10 power minus 2 Tesla. So మీరు ఈ ప్రాబ్లం కూడా ట్రై చేయడం చేయండి. అండ్ speed of velocity of the particle is given into 6 into 10 power 27 meter per second. So if the specific charge of the electron and the chadu 1.7 into 10 power 11. So is asking to find, so sorry Andy, it's a coulomb per kg. What is asking? Asking to find the radius of the circular path. Okay, what is the formula radius of the circular path? What is the formula? Last class we discussed. It's a R is equals to mv by qb. The radius of the circular path is equals to mv by cube. Okay, so in the question what they are given, so electron is moving right angles, so carbon theta is equals to 90 degrees. So here the magnetic field is equals to 1.5 into 10 power minus 2 Tesla, and the velocity is given 6.10 power 27 meter per second, and the specific charge ichchadu ikkada. Right?
Options, sir.
Huh?
Options.
Options. So option A 2.9 centimeters, option B 3.9 centimeters, option C 2.35 centimeters, and option D 3 centimeters. So ikkada specific charge ichchadu. ఎంత ఇచ్చాడు స్పెసిఫిక్ ఛార్జ్ 1.7 into 10 power 11 into coulomb per kg. అందుకని నేను బ్యూటిఫుల్ ప్రాబ్లం అండి స్టార్టింగ్లో. సో స్పెసిఫిక్ ఛార్జ్ అంటే ఇక్కడ ఇచ్చింది మనకి యూనిట్స్లోనే, ఛార్జ్ పర్ కేజీ అంటే ఛార్జ్ పర్ మాస్, కాబట్టి ఛార్జ్ పర్ మాస్ క్యూబైఎం. సో మనకి క్యూబైఎం దీంట్లో నుంచి రావచ్చు, మనకి ఈక్వేషన్ ఎట్లా రాసుకోవచ్చు, Q/m into B. B value తెలుసు, V value తెలుసు. Please substitute 6 into 10 power 27 and divided by, what is the Q/m? Q/m is given by 1.7 into 10 power 11, and magnetic field is given by 1.5 into 10 power minus 2. So this is going to be 1.5 is 1.7 and then 1.7. Please tell me what is the answer. So 255 and 2.55. So it's a 6 by 2.55 into 10 power 27 divided by how much this is going to be. So 9. 10^9. సో మనకి ఎంత వస్తుంది, ఇది రౌండ్ ఆఫ్ 3 వేసుకోండి, మనకి ఎంత వస్తుంది, సో 2 into, సో నియర్లీ 10 power, how much it is, 19. Yes, it's a 19. So 10^9. ఆప్షన్స్లో మనకి సెంటీమీటర్స్ ఇచ్చి, ఎస్ హర్షి, raise the hand and where is the chart box? In a chart box. Denominator 10^11 అండి. సో -2 ఉంది కదా, ఇట్ ఈస్ గోయింగ్ టు బి 10^9. I think this value 17. Okay, let's take this value is the 17. 17 in
2.4.
it's a 17 and 25.5 వస్తుంది. సో ఇప్పుడు మన ప్రాబ్లం చేసినా కూడా ఇలా వస్తుంది. దిస్ ఈస్ గోయింగ్ టు బి 10^17. సో ఇక్కడ 70 into 10^11 into 1.5 into 6 divided by 25. So really you can make it as a 26 వేసుకున్నాం. అండ్ ఇది ఎంత, సో 9. సో దిస్ ఈస్ గోయింగ్ టు బి 10^19. 10^19 కింద మిగులుతుంది 9 కండి మిగలేదు, 10^18. This is going to be 18. So why the answer is coming in centimeters? Can anyone find the answer from this? The data is wrong, na? Please say C, sir. No, Toyajax, it's not a C. So the options are wrong, I think so. Please have you solved this problem. So how much you will get? So 13 into 3. And I will get 4. So we got 0.223 into 10^18. If I make it 2.3, so 2.35 into 10^17. You have to get in terms of the 70. But why here we got? Yeah. So there is some option is not there. What's a P by Q? 2.14 into 10^-12. -12 వచ్చిందండి. -12 ఎట్లా వస్తుంది? మనకి 18-17 ఆగిపోతుందండి. Okay, so nearly, yes, okay na? This is the answer. These options are not correct. Okay, let's take the second question. Wait, sir. Yeah, Kushi. Wait, we just saw the problem.
సెంటీమీటర్ రావట్లేదు సార్ 2.4 వస్తుంది సార్
పవర్ ఏం రావట్లేదా?
పవర్ సెంటీమీటర్స్ లో రావట్లేదు సార్.
అచ్చా 2.4
2.4 వచ్చింది సార్. 10⁻15 వచ్చింది సార్.
నేను అదే అంటుంది. ఇట్స్ ఓకే. వాల్యూస్ ఇట్స్ ఓకే. ఇట్స్
సెంటీమీటర్ రాదు.
2.35 into 10⁻17 meters. It's okay, fine. The second question. So the electron, the mass of the electron, they given 9 into 10⁻31 kg, and the charge of the electron is equals to 1.6 into 10⁻19 coulomb. I'm not writing all the data, and I think no necessary. Kinetic energy is given 7.2 into 10⁻18 joules, and is moving in a circular orbit. Okay, condition is the moving in a circular orbit. This is the condition, and is given that magnetic field is 9 into 10⁻⁻5, so Tesla, and he asking to find that what is the radius of the orbit. Kinetic energy ichadandi. Please be careful. 10⁻7 velocity. 10⁻7 వేస్తే మనకు ఆన్సర్ వస్తుందా? ఎస్. ఇక్కడ 9 ఉంటుంది, పైన 7 ఉంటుంది, 10⁻−2 వస్తుంది. ఎస్, అప్పుడు మనకి 0.23 సెంటీమీటర్స్ వస్తుంది. ఎస్ అండి. Okay, we have to take the 10⁻27 only. Yes, as per doubt. Oh, okay. So maybe there is a mistake in the material. అయితే మన క్యాలిక్యులేషన్ లో మిస్టేక్ లేదు. అది
మెటీరియల్ సార్.
థ్యాంక్ యూ హర్షిత్.
మెటీరియల్ ఏంటి సార్? మెటీరియల్ నేమ్ ఏంటి సార్?
హలో, wait. Is it disconnected? Voice is not audible. Is my voice is audible? Sorry, and 1 minute, it's disconnected. Voice is disconnected. That material is given by the company and for us for teaching. Hello, is it okay right now? So suddenly disconnected.
So options 7 sir.
Yes, now voice is correct. Yeah, now connected. So please find that answer, and options is A is equals to 1.25 centimeter, and B is equals to 2.5 centimeter, and C is equals to 12.5 centimeter, the D is equals to 25 centimeter. Find that solution. Which formula you have to use? So మనం చాలా ప్రాబ్లమ్స్ ఇచ్చాము. Which formula you have to use?
mv by bq sir.
Yes, R is equals to mv by bq. Okay, so మనకి మాస్ తెలుసు, చార్జ్ తెలుసు. but here they didn't give in terms of the kinetic energy, right? So what is the mass into velocity, momentum, and VQ? What is the momentum relation with kinetic energy? Sir, it's 2 me or k divided by VQ. It's a root of, right? సో హియర్ మనకి ఏమి ఇచ్చాడు, ఇక్కడ మనకి మ్యాగ్నెటిక్ ఫీల్డ్ ఇచ్చాడు, మ్యాగ్నెటిక్ ఫీల్డ్ వచ్చు, చార్జ్ ఉంది, మాస్ ఉంది, kinetic energy is there. Please substitute and find the answer. So 2 into what is the mass, 9 into 10 power minus 30, energy is equals to 18 joules and divided by, and 9 into 10 power minus 5 into what is the charge? Charge is equals to 1.6 into 10 power minus 90. This is square root and all square root. So this is the square root of, then let's see how much this is going to be. 7.2 times 7.2. So 14.4 into 9 into how much? 10 times of 49 divided by root, and this is going to be 1.6. So here also 14.4 into 10 power minus 24. So this is going to be, calculate the 14.4 and calculate the 14.4 into 9.
Uh,
129. సారీ అండి, నాకు వాయిస్ వినపడట్లేదు ప్రయోజనం.
sir.
Yes. Yes, sir. లేదా మళ్ళీ తప్పు చేశాను. Oh God, there are lots of mistakes in this. Okay, and it's not 18, it's 8. So consider this is 8 minus 8. This is a minus 8. Now this answer is going to be minus 8. It ఎంత అయిపోతుంది? 23 అవుతుంది. Yes, it's going to be 23. And denominator charge
ఇదైతే సెంటీమీటర్స్ లో
రావట్లేదు కదా సెంటీమీటర్స్ లో. Yeah, it's lots of mistakes.
18 minus 18.
లేదండి, ఆప్షన్స్ it should come like this. Okay, so this material is not good. You should not follow this one.
Kinetic
Okay.
energy answer.
Kinetic energy 7.2 into 10 power minus 8. Take this one and substitute. So 1.6 into 10 power minus 19, and B is equals to 1.5 into 10 power minus 5. But no, minus 5. Minus 5. Hello? హలో
సెంటీమీటర్స్ లో రాలేదు సార్, -8 తీసుకుంటాను.
Okay, leave this question, don't do these questions. Okay, we'll take the, I will take the some other questions. Okay, and it's okay, don't do these questions. I will take some other questions. I will bring the good questions from tomorrow. I will bring the tomorrow questions, and we'll talk the tomorrow. It's we are going to talk about the Lorentz force tomorrow. So we'll complete the Lorentz force tomorrow, and there is a one concept on the Lorentz force. Then we have to talk about the next class between the force between the two parallel conductors. So then we are going to talk about the force between the two moving charges. So e concept could important and so then we are going to talk about, we are going to solve some problems on that one. Lorentz force and force between the two parallel conductors, and we are going to talk about the, then we are going to talk about the dipoles, magnetic dipoles. Okay now, so after this this magnetic field chapter will complete. After the magnetic dipoles, then we will move to the magnetic induction. So in the magnetic induction, we are going to talk about the magnetic materials. In the magnetic materials, there I am going to explain that the relation between epsilon and the refractive index. Okay, and hope this understand. Don't do this question.
Sir,
I will share the notes. This
Sir.
question only I will share. Yes, Sandeep.
అది 25 into 10 to the power -12 వస్తుంది సార్.
This one. Actually, there is some data mistake is there. Before I take the question, first I have to solve the question. Then I will explain and otherwise class is not going to be good. Okay, don't take it today. Bhagya, how to a family safety? What is this? Now I will see that chat box as per doubt not. Okay, entity name. It's sent by the company and for us. Kushi, what is 9? Tejakshinu. Bhagya, how to have family safety? What? How to have family safety? నాకు అర్థం కాలేదు భాగ్య హర్షిత్. ప్రజ్వల్ ఇంగ్లీష్లో మాట్లాడాడు. మైక్రోసాఫ్ట్. వాట్ మైక్రోసాఫ్ట్? యూ వాంట్ సత్యనాథెల్ల ఫోన్ నెంబర్. గయా. ఓకే అండి, సో యూ విల్ కంటిన్యూ ద క్లాస్ టుమారో. సో థ్యాంక్ యూ వెరీ మచ్. మీరు రీచ్ అయ్యారా ఇంటికి టైంకి? టైం పట్టిందా? 6:30 క్లాస్ వదిలిన తర్వాత మీరు ఇంటికి వచ్చేసే టైం పట్టిందా? 7:30. ఓకే హర్షిత్. మీరు డైరెక్ట్గా 7:30కి వచ్చి ఇంకా డైరెక్ట్గా మీరు బ్యాగ్ పక్కన పడేసి ఇంకా ఫోన్ తీసుకొని ఇంకా జాయిన్ అయినట్టున్నారు అంతేగా? ఎగ్జాక్ట్లీ. ఎస్, వాట్ సార్, ఐ థాట్ యూ విల్ నాట్ టేక్ ఆన్లైన్. ఎస్ అండి, సి ఐ ఆల్సో డోంట్ వాంట్ టు టేక్ ఆన్లైన్ క్లాసెస్. సో బట్ నా, సో yesterday I told I will not, morning koda I told I will not take the online classes, but na they gave emphasize me. Yes, let's see, but they told that they're telling me that 12 students are asking me. So 12 students are asking me that and the company told me that 12 students are forcing us to take online classes, so that's why they are giving it. So parledu, but we make online section is a very interactive session, don't worry. So ever miss kaakunda will take that nenem cheppledandi Kushi, we talk that what force? Magnetic force. We are going to take magnetic force. Yes, we are going to talk about the Lorentz force, and next class we are going to talk about the forces between the two line conductors. 12 students forcing. అచ్చా ఆ ఫోర్స్ మీరు అంటుంది ఏమో అండి, లైక్ ఇట్స్ ఓకే, డోంట్ వరీ. ఈవెన్ ఇఫ్ దే గివెన్ ద ఆన్లైన్ క్లాసెస్ వీ కెన్ మేక్ ఇట్ ఈస్ వెరీ ఇంటరాక్టివ్. సో ఐఎమ్ ప్లానింగ్ టు స్టార్ట్ ఐఎమ్ స్టార్టింగ్ టు ఆన్ వీడియో కాల్ అండి. సో ఐ విల్ సీ యూ కెన్ సీ మై వీడియో ఆల్సో. I will also see your video. Okay na? So it will going to be interactive. If I will take the online classes, definitely online classes మీకు యూజ్ ఉండేటట్టుగా నేను చేస్తాను. అంతేగాని ఇట్లా కెమెరా ఆఫ్ చేసి ఏందో నేను టీచ్ చేస్తున్నాను గాల్లో మీరు వినేస్తున్నారు అలా అయితే నేను అసలు టీచ్ చేయనండి. ఐ విల్ నాట్ దట్ లైక్ కైండ్ ఆఫ్ టీచింగ్ ఆల్సో. ఇఫ్ ఐ టేక్ ద క్లాసెస్ యూ షుడ్ బి గెట్ బెనిఫిట్. Otherwise, no, it's not at all useful online classes. I will see if it is possible, then I will take online classes. If it is not possible, I will not take the online classes. Okay, just bear with me for 2-3 days. I will arrange the proper system. Okay, everyone. So thank you very much. We're leaving the class today. We'll meet tomorrow. Yes, Harshit. Or Harshit. Prajak, Chapandi. Yes, Kuishi, Chapandi. What happened yesterday? Yesterday it was a completely difficult day, so I have a difficult to teach. There is a lots of noise and everything. Yeah, happy Deepavali. Lots of noise. That's why I didn't feel good to take on. That's why I quit. I told them that I will not. But again they gave me. Let's see what will happen next class. Okay, na? Thank you very much. So please now take dinner, fresh, and take dinner. How is the health? Yeah, everyone's health condition is good, and so my I think my health was just a record recently. Thank you, Harshit. Thank you for asking. Okay, students, good night. Please take rest and take dinner and take proper sleep. Okay? We'll meet tomorrow. Thank you very much. Thank you.